Hello, everybody. Good afternoon, and welcome to I Love Science. I'm very happy so many of you are joining, and I get a lot of messages from many of you that you are enjoying these sessions, you love science, and when you say this, it makes me more happy, right? Okay, so as I told you yesterday, our today's session is about toys, and all of you love toys, right? So today we will actually merge toys and science together. So I will tell you, and you will be able to make a lot of toys, but not only fun from toys, we will also understand the science of those toys on how do those toys work. All right. So let's start. I have about 6, 7 type of toys that I will cover today, and mostly you should have the material and you should be able to make them at home. All right. Okay. I know some people sent me the message that please tell us what material will be required today. I'm not doing that because I know that you will not be able to make those toys during this live session, right? So that is why just relax, see the video, and after we finish the live session, then you will be able to make those toys. Also, in today's session, I will be using some designs which you may find a little difficult to make at home. So I have uploaded those designs on my website. I will tell the link of those files later, and then you will be able to download those designs so that you can make those toys properly. All right. So let's start. We will start with a very interesting and fun toy. A lot of people like that, and that is a little balancing toy. All right. So let me make the toy and then I will explain the science of that toy, right? So I'm taking a little, this eraser, simple eraser, insert a toothpick at the bottom. And now see, the challenge is that can you balance this toothpick in your finger? Can you balance this eraser in your finger? And it will be almost impossible, extremely difficult for you to balance this. Now, so let me tell you what is the science trick to balance this in your hand. So what I have done here, I have taken 2 long toothpicks, or these are called skewers, attached one solid rubber ball, or what we call crazy balls, at the end of these 2. Okay. And now we will attach these to this eraser slightly tilted way at this angle. All right. So we do this, and now science has done something to this eraser that now it will be very easy to balance on your finger without any problem. All right, let's see this. So now it has a good balance. I mean, even if I try to tumble this like this, it will not fall off. See? So it will keep rotating. It will go here and there. Okay, but it will not fall from my finger. I can adjust the angle a little bit so that it can stay straight. Yeah, see? So now what made the change that it is able to balance itself now so nicely? All right. So now I will explain you about the concept of a center of gravity, or it is called center of mass. Both the terms mean the same thing. But the concept is that anything which is one solid object. So for example, right now, this whole thing is combined together as one object. Now, where is it, which side of this object is heavy? So you see, these 2 balls are heavy, and they are actually heavier than this eraser. So the center of the mass of this object is actually somewhere here at this point. And this point somewhere here is actually below the point from where I am holding this. So it has a stable balance. Okay. But if I detach these, both of these, then this whole thing, its mass is up here. Okay. So its center of mass is up here, and then it's very difficult to balance it. It will always fall down. Okay. So what happens is that if anything has center of mass which is low, which means it is lower, then it has a very good and stable balance. All right. Now, I can show you some more fun ways that you can do at home. Not only your finger, I can actually attach it like this. Children enjoy this very much. I can actually attach it like this, and it still doesn't fall. right? So it's a lot of fun. Children enjoy this little toy. Now understand the concept between stability and center of mass. You may have seen sometimes that some vehicles, like some trucks, when they are going on the highway and then they tumble over. Now, why do they tumble over? Even if there is no accident, even then they tumble over and fall down. And it happens more with those vehicles or those trucks if they overload themselves very high. In that case, what happens? Their center of mass or center of gravity shifts very high and they have unstable balance. But if a truck has loaded everything at a lower level, then it will have a stable balance. So what you should remember is that anything which has its center of mass low, it will have a stable balance. If its center of mass is high, then it will have an unstable balance. All right. So this is the concept, and you can make such simple toy from this.
Can we use anything other than crazy balls?
Yes, you can. So good question. Can we use anything other than crazy balls? Now I didn't have. So actually you can use two more erasers here. Okay, I didn't have more erasers, so I did not do this. But you can attach two erasers here, and then you can make the same toy. It will be possible. But wait, I will tell you two more variations of making the same concept. All right. So this is done. Now let me do the same thing with this little potato, right? So let's see. Can you balance this potato on your finger? No, you cannot balance it, right? Why? Because the center of mass of this potato is here, which is above my finger, above this finger from where I'm trying to handle this. So it will always fall down. Now, how can I bring the center of mass below? So let me do a little trick. I will attach some forks on both sides. And all right, now what has happened? Now I have two metal forks here, right? And so these are metal forks, they are heavy. So again, the center of mass of this whole object is somewhere here, all right? Somewhere here at this point, because the mass of these forks is also there, right? So now if I try to balance it, it's very easy. It will not fall off, see? So now it becomes a stable balance, and even if I try to tumble this, it will not fall off. So this is another version of the same toy that you can do with simple things. I mean, you don't need too much. You just need two forks and one potato, and then you can do this, right? So this is another. I mean, if you want, I can show you another simple variation of this. I should be able to balance this potato on my finger on a toothpick also, right? So let's see if I can do this. No, this toothpick is too long. Let me use a smaller toothpick, because yeah, it's still very long. So yeah, see this? Okay, so I can do this. So on this little point here, I'm able to balance this. If it is tilting on one side, that means the center of gravity is actually going this side. So what I can do, I can remove this toothpick and then insert it from that side, the side on which it was tilting. And then you will be able to do that. So let me move quickly, otherwise I will not be able to cover all the toys. So I have done two versions of the balancing toy. I have a new thing. You may have seen a little toy, which is a large, balloon kind of a toy, and it's a clown, and then it says "hit me." You hit the clown toy, and then it falls down, and then comes back again automatically. So let's make a very simple toy, which is again on center of gravity. So for this toy, what I have done, I have taken one long stick and two smaller sticks, attached them with a tape, all right, and then. Okay, so let me just complete this, and I am attaching a ball here. So now it looks like a person. It's a stick figure of a person. Now I will try to make that toy. So again, I am using a potato, but this time you will see I am taking a bigger potato because I want the center of gravity to be lower, right? So now if you see, if I put it here, and let's see if our toy works. So this one, if you tumble it like this, you tumble it like this, you send it like this, you send it like this, it will not fall down, right? So it's a nice toy and it has a very stable balance. The concept of stable balance is that if you shift the thing from the mean position to either left or right, it comes back to the center position. Then it is a stable balance. And that is what is happening with this little toy. So you can make all these toys at home, very simple mechanism, and understand about center of gravity. All right. So in this case, center of gravity is here below it. Okay. So that is why it has got a stable balance. If I use a small potato here, which is lighter, then this will not be able to balance, because then maybe the weight of the above structure is more and the bottom structure is low. So you should always have heavy thing at the bottom to make it stable balance. All right. So this is another toy we made. So there are 2-3 toys we have made on stable balance and center of gravity. So let's move. We will do some spinning toys now. Okay. So let me do the fun spinning toy first. Okay. So I will make a balloon spinner. All right. So let's see how to make a balloon spinner. So I am taking a balloon, and this is a simple bendy straw. I mean, all of you have seen that these are the straws used for cold drink, and they can bend like this. So I can insert the straw in this and then close it using a rubber band. So let me do this. Close the mouth of the balloon so that the air does not leak from the mouth. So are there some good fun comments? No, nothing to mention. All right, no problem. Okay. Okay. So now let's see how do we make a spinner from this very simple thing. Okay. Now this one will work on a different science concept. This is similar to the day one when we discussed about Newton's laws. So let me just show you how to make this work. So we will try to use it on the floor. So come here. Okay. Now let's see. So the balloon has been inflated. I have put a rubber band on the straw so that it doesn't, the air doesn't leak. And I have to make sure that the straw is bent. Now, if I leave it here, then see what will happen. Yes. So did you see? It's such a simple, fun toy to make, a little spinner which works on the Newton's third law. Now, what is Newton's third law in this again? We learned that on day one. The air comes out from the straw, but because we have bent the straw, it doesn't come out straight like this. It comes out at the angle. Now, when it comes out at this angle, then the opposite force in this comes here, and because the balloon is resting on the floor and the force comes here, so it keeps rotating like this. So that is the concept. Now, the similar concept is used on some other toys. For example, the charkhi that you use on Diwali, right? So that also works on that same concept. So you put fire in that charkhi, it burns on one edge, fire comes out in one direction, and it starts rotating in the other direction. Okay. So this is another fun toy that you can make. Very simple, but understand the science behind why does it work like this. All right. So this is that balloon spinner. I have one more spinner that I thought I will show you. Now this is a very simple spinner. Let me just try to use it first, and then I will tell you how to make it. So this is a blow spinner, right? So let me just see how to make it. Let me show you how to use it. Okay, so you just blow from top. There is a lot of friction from the cloth. So let me use some plastic sheet. Yeah. Okay, so let me put on the plastic table mat. Then it will, spin faster. So you see, I'm simply blowing into this, and it starts rotating automatically. Now let me tell you how to make it, and then I will also explain you the science behind this and why this simple science is so useful for us today. All right. So let's see how to make this. What you have to do for this is take a simple cardboard sheet, cut a circle from that. You can make it using a compass, approximately 2-inch radius. Make a circle, and then after that, divide this into 8 equal pieces. Okay. So from the center, draw these lines into 8 simple pieces. And now we will cut these lines up to only half the length. Don't cut it up to the center. All right. So let's see. Okay, so I have cut all these 8 lines up to about a little more than half the length so that we don't cut it up to the center. Now each of these lines, we have to fold it from here, and I will show you at what angle I am folding it. So you see, so I had cut this line up to this point, and then I am folding this edge here like this. Okay, so that a little triangle is coming up. So let me do this with all 8 corners. Right.
Will this spin on water?
Okay, so there is a very interesting question. Will it spin on water? No, because if you want anything to spin on water, it should be lighter than water. It should float. Okay. So this is spinner. It will not spin on water because it may actually sink in water, and also if it touches water, there will be a lot of friction. So let me tell you a few more tricks to make it spin nicely. All right. So you see, now we have bent all those 8 edges so that 8 corners are coming up. All right. And now to make it spin properly, we have to put something below it so that there is no friction. Okay. So I'm using a simple thumb pin like this, right? You can see this thumb pin. So we will use this thumb pin, put it in the center from the bottom. So I'm just making a hole from top because on top I can see the center. Put it from the bottom. Okay. Now what happens, because of this thumb pin at the center, it becomes very smooth because metallic, and then it is round like this at the bottom, this thumb pin. All right. And now I should be able to use this spinner. So you see, such a simple toy. Okay. Now what is science in this toy? Okay. Now there are 2 things that I would like to explain to you. Number 1, friction. So understand, why did we put this thumb pin at the bottom? To reduce friction, so that otherwise the whole paper circle will have friction from the surface, whether it is plastic or cloth or whatever, and because of the friction it will not spin. But the basic question, why does it spin? Okay. Now you see, because the shape of these fins or these blades is such that when I blow from the top, the airflow gets spread in all the direction, and then it pushes each fin in such a way that it starts rotating. Now this motion is very important for us because this concept is used to actually generate electricity from air. So you must have heard about the windmills. So windmills are actually used near, say, mostly they are used at the place where there is continuous wind all the time. For example, near sea beaches and all. Okay, and when the wind blows, it starts turning the blades of the generator. It starts turning, and then that energy is used to generate electricity. Right. So that is the concept. So that is why, though it is a very simple toy for children, but you understand that converting airflow into rotatory motion is very important, because that is used for generating electricity from wind, and that's a very good way of generating energy, because this method does not have any pollution. Okay, so this is a very nice thing to know, and then you can use this. This little thing, though I told you how to make it, but if you want, we have also uploaded the template of this design on our website. Later in the description of the this video, I will put the comments and give you the link how to download that. All right. So this is another toy. So we have made 2 spinners, one balloon spinner and one blow spinner, and both of them work on different principles. This one was on Newton's third law of motion, and this one is about the airflow and the shape of these fins, and then you understand how this action is very useful for generating electricity also. All right. So this is another toy. All right, now we will make another toy, and this will be a lot of fun for you. And this toy is a catapult. Okay, so this catapult, I am using these simple ice cream sticks. You may have a few at home because these are typically used by children to do craft or something. Okay, so let me do quickly how to do this. So first I am taking about 4 of these ice cream sticks. Okay, and tie them from both ends using rubber bands. This side, okay, and also from this side. Okay, so just tie them like this, leave them. Now I will use 2 more sticks. Okay, 2 more sticks, and then tie them only from one end this time. Okay, so I will use another rubber band and tie this very tightly. This one has to be very tight so that it doesn't open, because we are tying it only from one side. Okay, and so this becomes like this. Okay, now this one, so you see these are 4 ice cream sticks tied from both ends using rubber band. This one is 2 ice cream sticks tied only from one end, but this one has to be tied very tightly. Okay, and now we will put it here like this. Okay, so you can see this, and now this has to be secured here so that this attachment, this forceps or chimta kind of a thing, does not move from the base. Okay, so we will use a few more rubber bands and then put it tightly on this, this way and this way. You can bring the camera a little closer. Okay. Yeah. All right. So you see our assembly of the catapult is ready. So we had these 4 ice cream sticks attached on both sides, then 2 ice cream sticks attached on only one side, and then that fork or forceps type of a thing we have attached at the base and secured it with a rubber band. So now you see it can bend like this. All right. Yeah. Okay. Now let me complete this. So to make the catapult work, we will use a little double-sided tape. Where is my double-sided tape? Yeah. Okay. Okay. So I will take a little piece of double-sided tape, and I will use a bottle cap. Attach the tape on the bottle cap, and then I can tie it on the. All right. So our catapult is almost ready. All right. So I think I made one mistake. Let me do this again, because it has to be attached in such a way so that I leave a little edge on this thing so that I can press it properly. So let me use another piece of tape. Okay. All right. So you see what is the mistake that I made? This bottle cap has to be a little away from this edge. You can bring the camera a little closer. It has to be so that I have space from where I can press this. So leave a little edge of the ice cream stick here. Yeah. So now I will be able to press it from here. Right. So our catapult is ready, and let me use this catapult toy, and then I will explain you the science behind this. So I have a little TT ball. I can keep it here. You can use a TT ball. You can use a little bead or anything which is not heavy. Put it here. Hold it tightly. Okay. And then bend this here. Okay. So you see, when we are bending it, the ice cream stick is also bending, right? So let me just do this. Okay. And when I do this, if I leave it like this, then So my catapult is working, right? You saw? So let me use, this time I'm putting a little bead in this cap, and then see if I can throw the bead a little farther. 1, 2, 3, right? So you saw the catapult is working. Now let's see what is the science behind this little toy. Now the science in this little toy is that when we bend or stretch anything, then that material, if it is not broken by bending or stretching, then it tries to come back into original position if it is flexible, right? So by bending this ice cream stick, okay, it tries to come back because it is a little flexible like this. So this is similar to that dhanush baan, that bow and arrow that you use, right? And so when you stretch the bow and arrow, then the wooden bow actually bends and then it tries to come back. Now by bending the wood, whether it is this stick or the bow in the bow and arrow, we are actually storing the potential energy inside that wood, right? And when we leave it, then the potential energy converts into kinetic energy. So and then that kinetic energy throws the object at a high speed. Right? So whether it is bow and arrow, where the arrow goes with a high speed because the bow which is bent, the wooden bow which is bent, comes back into position, converts its potential energy into kinetic energy, and the similar concept works here, right? So again, as I said, this will work well if you have some light thing into this because it's a little thin piece of wood. Yeah, give me this, okay? And so let me do it one more time, and let's see if I can throw this a little far this time. So 1, 2, yes, right? So this is how the catapult, you can make this little toy and understand the concept of storing the potential energy inside the wood. Now the same concept happens in rubber band, right? So for example, when you stretch a rubber band, then you are actually storing the potential energy inside the rubber, and when you leave it, then if it's something is there, then that thing moves with a high speed, which is converting the potential energy into kinetic energy, right? So this is another toy that we made, and I explained you the concept of potential and kinetic energy inside that toy, right? Okay, so I have one more toy for today's session, okay, and which is a little woodpecker, right? So I have a little woodpecker. Now you know how the woodpecker sits on a tree and then keeps pecking the trunk of the tree, cut, 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 like this. Okay, so we will do something so that this little woodpecker also moves in the same way, right? Now this design, I have made it here I have actually drawn it here, but for those of you who find it difficult to draw like this, or you want the actual dimensions and all that, this is another file which I have uploaded on the website. I will give you the link later in my video description, how to download this. Okay. Now let's see how will we make this. I forgot to bring the Fevicol. So can you bring the Fevicol from there? And we will need a little piece of straw. Okay. Okay. Thank you. All right. Okay, so this, you see, we have this woodpecker design on both sides and a strip in between. So what I am doing to make this toy is just put the Fevicol on one side, right? So that I can stick this whole thing together. And in the center, I will put this piece of straw so that it gets stuck here. Close this whole thing. Okay. And I will have to wait for a few seconds so that the Fevicol dries. Okay. And yeah. All right. So let's see. What is this little toy? Okay. So we will use, we can use either a thread or we can use a piece of long. Dipali, can you bring some? There is a thread roll that side. I forgot to bring. These are very small pieces. Yeah, thank you. Okay, so let me take a long piece of thread from here. Yeah, I will put this thread through the straw, and let's see if I can make the woodpecker move in a very interesting way like the real woodpeckers do. Yes, can you see the motion of the woodpecker? It's moving so nicely on my thread. Okay, let me do it again. And this will work only if you hold the thread tightly. Okay, and then let's do it again. Nice. Did you like the toy? Okay, now let's understand what is the science in this toy and why is it moving in this jerky motion like this. Now the reason for it to come down in this jerky motion is actually the friction. So you see, when this straw and there is a thread inside the straw, when it moves it like this, then because of the friction, the thread tries to stop the toy. It holds it and then it changes angle, then moves a little again, then because of the friction it stops again, and then that keeps happening. So while the gravity is pulling the toy down, the friction is stopping it in jerks, and then it gives a very interesting movement to this little toy, and it moves in such a way as if the woodpecker is pecking on the trunk of the tree, right? So yeah, so that is all the toys that I thought we will have today. So it's already time. I hope all of you are enjoying this. Let me talk about one or two other points. A lot of people sent me videos yesterday of their children saying, I love science, I'm very happy, and then I want more of you, you can send it to me. Some people sent me messages that some of their friends don't have Facebook accounts, so how can they watch these videos? I'm going to upload all these videos on the YouTube channel of I Love Science, so I will start uploading that today. And if your friends, those who don't have Facebook account, they can watch it from YouTube. I also want to tell you that if you want to use the science kits from I Love Science, you want your school to use science kits from I Love Science, then you can talk to your science teacher or some senior teacher or principal and tell them about I Love Science, and then we'll be happy to talk to them and then supply science kits at your school as well. Right? So that is all for today. Enjoy and send me your comments and feedback. Thank you. Bye-bye.